Hello, Martin and I are doing the module 15.
Got the introduction. Hello, friends of chemistry. This is review questions from module 15.
Thank you. And what page are we on?
We're on page 522.
Thanks. Please read number 1.
What is the definition of chemical equilibrium?
All right.
That is defined on page 492. Chemical equilibrium is the point at which both the forward and reverse reactions in a chemical equation have equal reaction rates. When this occurs...
Right.
Oh, you're writing all of it.
Forward and reverse
reactions in a chemical equation have equal reaction rates.
Of equal, I'm going to leave out of a chemical equation because that's what I'm talking about. Of equal reaction rates. Good? When this occurs,
the amounts of each substance in the chemical reaction will not change, despite the fact that both reactions will proceed.
At equilibrium. The amount, say it again.
The amounts of each substance in the chemical reaction will not change, despite the fact that both reactions will still proceed.
So, they have equal reaction rates, and the amounts of substances will not change.
Yeah.
Those are the two important things to note about chemical equilibrium.
On to number 2.
Number 2.
Does a chemical reaction actually stop once equilibrium is reached?
We kind of just discussed that in question number 1. What did we say? We said
it does not stop.
That's right. They have equal reaction rates. The amount of substance will not change, although the reactions continue to occur, right?
Yeah.
So the reaction doesn't stop, although the amount of substances does not change. Number 3.
A chemist is studying the two chemical equilibria.
Just two chemical, not the two.
Excuse me. Do I correct you on your adjectives? Yes, I do. The first one has an equilibrium constant equal to 1,213 molarity, while the second has an equilibrium constant equal to 0.344 molarity squared. Which reaction
Sorry, what is it?
0.344 molarity squared. Which reaction will make more products?
How can you tell? So this is the constant. Where do we get the constant from? Where do we see the constant?
Constant is
comes from this equation, right? So we have the reaction rate at equilibrium is equal to K, some constant, times the concentration at equilibrium of substance C to whatever C is, its coefficient in the chemical equation, times D to the D, divided by A to the A over B to the B, with concentration. I'm not going to bother saying all those things. You should know them. But the K, as we know from having done lots of K equations, K often has different units. So when it has different units, it's because these exponents are different. So if I have, for example, molarity cubed over molarity, what K will I end up with?
Molarity squared.
Right. What if I have only molarity squared over molarity?
Then you end up with molarity.
Just molarity. So it sounds like we probably, so where are the products? They're in the numerator, right? So the more products we have, the bigger the exponent of the K will be, right?
Yes.
Okay, so that will help us answer the question. So we want to know which reaction will make more products. And again, the products are where?
Numerator.
They're the numerator. So which one will make more products?
The second one.
Yes, the one with molarity squared. Okay, because it has, this refers to the coefficients, right? So C, and that tells us how many products we have.
This was such an obvious trick question that this apparently smaller number was almost given to be the actual larger one.
Trick question, no. But the point is, it's not the number
Sort of a trick question
here that's important. This just has to do with the coefficient. This just has to do with the constant K, right? What we have to be looking at is the units of K. That will tell us about our products and how many of them there are, because that will give us the coefficient, etc. We're going to stop the video here and come back with a separate video for question number 4. Okay? All right. Thanks, friends of chemistry.